Hey Maya, how are you?
Good Vivek, where are you up to?
I am going to buy a light bulb.
You know light bulb gets lit up due to electricity.
What is electricity?
Hi everyone. Welcome to our YouTube channel AskPrep. In today's video, we are going to discuss about electricity. Electricity is the flow of electrical power or charge. Electricity is both a basic part of nature and one of the most widely used forms of energy. Electric current and circuit. Electric current is the rate of flow of electrons in a conductor. The C unit of electric current is the ampere. Electrons are minute particles that exist within the molecular structure of a substance. Sometimes, these electrons are tightly held, and other times they are loosely held. An electric circuit consists of a device that provides energy to the charged particles that make up the current, such as a battery or a generator, as well as devices that use current, such as lamps, electric motors, or computers, and the connecting wires or transmission lines. Electric potential and potential difference. The amount of work needed to move a unit charge from a reference point to a specific point against an electric field. Typically, the reference point is Earth, although any point beyond the influence of the electric field charge can be used. Potential difference is the difference in the amount of energy that charge carriers have between 2 points in a circuit. Potential difference, V, between 2 points is equal to work done, W, charge, Q. V is equal to WQ, 11.2. The C unit of electric potential difference is volt, V, named after Alessandro Volta. Ohm's law. Ohm's law states that the voltage across a conductor is directly proportional to the current flowing through it, provided all physical conditions and temperature remain constant. If the potential difference across the two ends of a conductor is 1 V, and the current through it is 1 A, then the resistance R of the conductor is 1, that is, 1 ohm is equal to 1 volt 1 ampere. Resistance. Resistance is a measure of the opposition to current flow in an electrical circuit. Factors on which the resistance of a conductor depends. 1. Material. The type of material from which a conductor is made plays a significant role in determining its resistance. Good conductors, metals like copper, aluminum, and silver have low resistance because they have a high density of free electrons, allowing current to flow easily. Insulators, materials like rubber, glass, and plastic have high resistance, inhibiting the flow of current. 2. Length. Resistance is directly proportional to the length of the conductor. The longer the conductor, the greater the resistance, as electrons encounter more collisions while traveling through the material. 3. Cross-sectional area. Resistance is inversely proportional to the cross-sectional area of the conductor. A larger cross-sectional area allows more electrons to flow simultaneously, reducing resistance. 4. Temperature. Resistance generally increases with temperature for most conductors, particularly metals. Higher temperatures cause more lattice vibrations within the conductor, leading to increased collisions between electrons and atoms, which in turn increases resistance. The temperature-resistance relationship varies based on the material's temperature coefficient of resistance. Resistance of a system of resistors. Resistors in series. 2 or more resistors are said to be connected in series when the same amount of current flows through all the resistors. In such circuits, the voltage across each resistor is different. In a series connection, if any resistor is broken or a fault occurs, then the entire circuit is turned off. Resistors in parallel. 2 or more resistors are said to be connected in parallel when the voltage is the same across all the resistors. In such circuits, the current is branched out and recombined when branches meet at a common point. Heating effect of electric current. The heating effect of electric current is well explained with a mathematical description given by Joule's law. Joule's law says that the amount of heat generated is directly proportional to the current flowing through the wire and the resistance of the material. Practical applications of heating effect of electric current. The generation of heat in a conductor is an inevitable consequence of electric current. In many cases, it is undesirable as it converts useful electrical energy into heat. In electric circuits, the unavoidable heating can increase the temperature of the components and alter their properties. However, heating effect of electric current has many useful applications. The electric laundry iron, electric toaster, electric oven, electric kettle and electric heater are some of the familiar devices based on Joule's heating. The electric heating is also used to produce light, as in an electric bulb. Here, the filament must retain as much of the heat generated as is possible, so that it gets very hot and emits light. It must not melt at such high temperature. A strong metal with high melting point such as tungsten, melting point 3380 degrees Celsius, is used for making bulb filaments. The filament should be thermally isolated as much as possible, using insulating support, etc. The bulbs are usually filled with chemically inactive nitrogen and argon gases to prolong the life of filament. Most of the power consumed by the filament appears as heat, but a small part of it is in the form of light radiated. Another common application of Joule's heating is the fuse used in electric circuits. It protects circuits and appliances by stopping the flow of any unduly high electric current. The fuse is placed in series with the device. It consists of a piece of wire made of a metal or an alloy of appropriate melting point, for example aluminum, copper, iron, lead, etc. If a current larger than the specified value flows through the circuit, the temperature of the fuse wire increases. This melts the fuse wire and breaks the circuit. The fuse wire is usually encased in a cartridge of porcelain or similar material with metal ends. The fuses used for domestic purposes are rated as 1A, 2A, 3A, 5A, 10A, etc. For an electric iron which consumes 1 kilowatt electric power when operated at 220 V, a current of 1000 by 220 A, that is, 4.54 A will flow in the circuit. In this case, a 5A fuse must be used. Electric power. Electric power is the rate at which work is done or energy is transformed into an electrical circuit. The C unit of electric power is watt, W.
Wow, that's good Maya. Now I should head out home.
Alright, bye. Thanks for joining us today. We'll continue making these knowledgeable videos for you in future. Until then, stay curious, stay informed, and stay safe.